All right, welcome back. And if you allow me to, I would like to sit down and talk for the next presentation. In consideration of the time that we have left for the discussion, I really have two different slides on nutrient management and two different presentations. And my first presentation is basically on the basic concepts of fertilization and nutrition. And then the second presentation is actually calculating the budget for nitrogen, the way we do the calculation with the pre-nutrient demand in California. So that one is the particular practical reason and practical knowledge. This one is the basic concepts. So I will probably rush through the slides of the basic concepts unless you really want to discuss that, because I have these slides and on the 7th when we are reviewing it, we can always spend more time, right? So I don't want to miss on the practical information as well. So let's go through the basic information. This is a list of macronutrients and micronutrients essential for plant growth. Nutrients are really supplied through the soil. The trees take up nutrients through the soil moisture, through the process of either diffusion or mass flow. It really depends on how big the nutrient pool in the soil is, how much nutrient availability is in the soil solution. And each nutrient has their own availability depending on the soil type and the type of the nutrient that you're talking about. There are other compounding factors like soil chemistry, for example, the pH and the cation exchange capacity, presence of lime, organic matter, all of those. And soil texture is really important for certain nutrient elements for the purpose of root exploration. For example, phosphorus. Phosphorus is an element that can actually get tied up to the clay particles. So the really roots have to grow out to explore the root zone in order to get enough phosphorus. So you have these considerations to keep in mind. For the effective plant nutrient uptake, you have to have active root growth. That is a requirement. So we talked about optimum temperatures in the root zone in the winter time, when the soils are near frozen at some places or soil temperatures are low, the nutrient uptake is low. Then water and oxygen are also required for nutrient uptake in the root zone. And then leaves are required because most of the nutrients are taken as part of the transpiration stream with the process of mass flow. In most, in California soils, nitrogen, sulfur, magnesium, and calcium, they are mobile and they're soluble in most soils. These nutrients can also be leached. We talked about nutrient leaching already. Potassium is typically, in some it's mobile, in some other soils it can get held up by soil. So the cation exchange capacity of your soil and your soil texture are really important to know when it comes to potassium nutrition and availability of potassium. And then there could be a significant interaction, for example, potassium with your soil salinity, your sodium content of potassium and even calcium. And potassium and calcium can interact with sodium. And in many California orchards, I have seen over the years what we call is sodium-induced potassium chlorosis. Even if there is enough potassium in the soil, when there is high sodium, that actually sodium interferes with potassium uptake and induces the chlorosis. Phosphorus, like I said, phosphorus has restricted solubility and movement in soils, so root exploration and root health is critical. So this is to explain the process of mass flow as the The nutrients are taken up as part of the soil solution based on the transpiration pull through the xylem stream. Some of the nutrients are also taken as part of the process of diffusion, and potassium is a good example of the diffusion process. The factors that affect nutrient uptake and utilization, of course, your irrigation system design and irrigation scheduling practices, they have a lot of influence on your nutrient uptake efficiency and utilization. The competition for weeds is really a big impact on your trees getting proper nutrition. The presence of hard pans underneath or the poor water infiltration because of salinity and sodicity, or perched water tables, alkali spots, all of those can affect nutrient uptake. And soil pH, we will talk about soil pH and nutrient uptake. Low soil temperature, we already talked about it. Low soil temperature means low root activity and low microbial activity. So, and then native soil fertility. Some soils really are high in some nutrients natively. For example, California soils are really high in phosphorus. So we rarely see phosphorus deficiency in California soils. And root diseases like verticillium wilt, it can affect uptake of nutrients. For example, wilt uptake affects the potassium uptake. Then there is issue of nutrient mobility within the plants. Each nutrient element is different in terms of how mobile they are within the plant system. Some nutrient elements can move freely in the plants from one place to another and back to the first place. We can call them the mobile elements. Some other elements we call them immobile because they can move from the soil to the target tissue, for example the leaves, and then they stay there. They cannot move back from the leaves back to the branches and other parts of the tree. So they would be defined as immobile nutrients. And the nutrient management for mobile and immobile nutrients is really different. For the general concentration, nitrogen, phosphorus, potassium, magnesium, and sulfur, they come in mobile category. They can actually move freely both in xylem and in phloem. So nitrogen, for example, nitrogen goes to the leaves, and if the trees are getting low, the new growth is getting low on nitrogen. The new growth can pull nitrogen out of the old growth. That's why we see the nitrogen deficiency symptoms first appear in older leaves, okay? Because the nitrogen can move from one part to another through phloem as well. So the fertilizer application strategies for mobile nutrients can be different in terms of, for example, you can apply nitrogen and it can have a long-term effect. It can move from one place to another. In case of immobile nutrients, for example, calcium and then zinc is in that category. If you apply zinc, the zinc stays where it is and it removes the deficiency at the tissue of its application, but the trees are really not going to move that zinc out of that tissue to a newer growth. So that's the reason why you see zinc deficiency in the newer growth, where you have the symptom, we call it little leaf.
Same is boron, yes?
Boron is, yeah. Boron is basically, it depends on the crop. It can be immobile to semi-mobile, depending on the crop. So this is the chart. So like it can be low mobility or completely immobile or free, right? So in case of almonds, you have the immobile elements like manganese, iron, calcium, and boron. Zinc, molybdenum, copper, and nickel, they have low mobility. Now this is leaf sampling. For effective nutrient management, what we have learned in California over the years is monitoring. We lay a lot of stress on monitoring. Around the year, we have a standard practice that we take petiole samples, leaf samples for nutrient analysis in July when the fruits attain full maturity but before harvest. So there is no net movement from source to sink in terms of fruits. So you get pretty standard contents, label levels. when you take nutrient leaf samples for micronutrient and macronutrient diagnosis in July. So taking leaf samples in July is a standard practice. Recently, the University of California has developed a protocol for early leaf sampling. They can take leaf samples as early as April, and that way they can have an advantage of adjusting the nutrient program within the same year. Because by the time you get your samples back in July, you take your samples in July, by the time you get your results back, it's already, the time is over for that season. So you cannot adjust, go back and adjust. So you can adjust for next year. So they developed the early sampling protocol for April, and they have different recommendations for that. Leaf samples, basically there is a protocol that you select about 10 leaves from around the canopy of the tree at the height about your eye level at about 2 meters from the ground, and then take the samples in a random fashion. You first divide your zone into different management zones based on variation, for example, soil variability, or based on your electrical conductivity variability. So if you have really different variable zones, so you address each zone as a separate sampling zone, and then you sample accordingly. And then you get the analysis done from a reputable lab. pH is a big factor, the soil factor that affects nutrient deficiency, and I will show you the next slide how pH affects particularly the uptake of micronutrients. Okay. Really the micronutrients like iron, zinc, manganese, they have, the pH has an important bearing on their uptake. So when I show this to my students in my class, I tell them to print this page in color and put it in their pocket. Whenever they go out and discuss nutrient management with a farmer, this chart is a good tool for reference. This chart shows that your nitrogen, phosphorus, potassium, sulfur, calcium, magnesium, they are taken up, the green color in the bar, they are taken up in the, very neutral to slightly alkaline pH, right around 7. But your iron, manganese, boron, copper, and zinc, they are best taken up at lower pH. So in California, some of the soils are really high pH soils, high alkalinity. So in this range, I have seen several orchards where your soil samples will show abundance of iron and abundance of zinc and copper, but your trees are deficient. And when you look at this chart, now you know where to address. Even if you are putting more iron or putting more zinc into your soil or putting more copper fertilizer into your soil, the trees are really not going to be able to take it up unless you use some EDTA, the chelates that bind with these nutrients and help the tree take that up. So there are really some management practices that you have to employ in order to have your trees take up, or you can lower your pH instead of putting in more iron. Yes?
What to do with boron, because there is no boron chelate. Boron is an ion, so it cannot be chelate.
Yeah. So if you have a low...
Sorry. What can we do? What can we do? Hello?
Hey, what can we do with boron? Because boron is not chelatable.
Okay. So for boron, there are really two. One, you can lower down the pH for proper uptake. Second, you can always rely on foliar application, because foliar application is, and the trees need boron as really essential. Still, it's a micronutrient, so the trees don't need a ton of boron. So you can easily correct the deficiency by foliar applications. If you really have to. So you can rely on that. Okay. Then there are. So then there are plant factors affecting nutrient deficiency. The fate of a nutrient can be different uses within the plant. It can be removed in the crop, or it can be demobilized within the tree system, and it can also get recycled when the leaves fall into the ground, and it can get into the soil. So the effective nutrient management, you have to work, and we will talk about the nutrient management strategies in the next lecture. You know, in California, we talk about like 4 rights: the right rate, the right time, right place, and right source. So those are really 4 things to think about when it comes to applying your nutrients. So you really need to optimize your nutrient application and meet the demand of the nutrients when they use it, and right rate of how much to use. There is a lot of debate in terms of single application versus split applications in a lot of scenarios, particularly suited to nitrogen management. We are advocating split applications over a period of time to actually do the split feeding. Yes. Yes.
And the last year, more or less, I have seen some studies about the silicon like a macro element. And I would like to know your opinion about the influence in nuts and almonds, walnuts, or pistachios as well. Because we don't have experience with this macro element, but in some universities start to talk, and some chemical companies to start to talk. And if you have any experience or any knowledge.
So I don't have an experience on working with silicon management or directly trialing with the effect of silicon on, let's say, almonds or pistachio trees, but I know from physiology that silicon is important in eliciting defense responses in the plant. So really stress responses or plant defense responses, triggering those responses, silicon is really, and I come across a lot of research papers when we discuss stress physiology in class, but for practical reasons, for practical applications, I have not come across a study yet in California situations where you would apply silicon. But I would be really interested in exploring that. So, basically, I will end up this discussion by discussing a few of these important elements and how they can affect the nitrogen deficiency symptoms. We see pale yellow color in the older leaves if the trees are deficient in nitrogen. So it can cause reduced shoot growth and shorter and thinner shoots. Potassium, you can have leaf symptoms. Potassium, typical potassium deficiency symptom is you have the tip of the leaves like browning and bending upwards. So you have that typical symptom, the chlorosis with scorched margins. And of course, potassium deficiency decreases the yields because potassium is important for fruit growth. Phosphorus, we don't really see much deficiency in terms of phosphorus, but if you have a phosphorus deficiency, you can get purplish tinge on the leaves, and the leaves can drop. Talking about the micronutrients, I have the slides talking about zinc, copper, and boron, 3 essential micronutrients in terms of almonds and pistachios both. We recommend in the growing season, it's a standard recommendation to apply zinc, copper, and boron mix at least during the season in pistachios as well as in almonds. That replenishes their levels in the tree. Role of zinc. Zinc is really important for a lot of metabolite and enzyme functions within the plants. And chloroplast and photosynthesis. Zinc deficiency, this is a picture from pistachios, but zinc deficiency can show similar symptoms in a lot of different crops. Symptoms would be little leaf, rosetting of the clusters, leaf clusters, the young leaves. They are small and clumped together. Factors affecting soil zinc availability, pH is one of them, and this is an example that each unit increase in pH can actually decrease the zinc deficiency by 100-fold. So zinc deficiency is really, really affected by small changes in pH. Copper deficiency, we have seen a lot of blind wood in copper deficient. It's really evident in pistachio trees, but I have also seen in copper deficient almond trees, you see the blind wood that the buds drop and the leaves drop. So copper deficiency can affect the vegetative growth severely. Again, you can apply the copper EDTA as needed if you have copper uptake issue. Just like zinc, copper is also applied at 50% leaf expansion when the leaves are really young and the cuticle is not developed. Boron is really important in flowering. We have already talked about the importance of boron in pollen tube development. So you can get deformed flowers, and the nuts can also develop become so these are the boron deficiency symptoms. You can get the leathery leaves and raised midribs. That's typical boron deficiency symptoms. We can also have boron toxicity symptoms. In California, we have scenarios where in some places boron is too high to toxic level, and you can get a salt burn on the leaves. This finishes the basic concepts, and I will pull up my next presentation on calculating nutrient budget, and I can take a question or two. Yes.
May I ask?
Yeah.
Okay. Let's take the ideal situation for the plant, the neutral pH and no salinity, and everything is okay. And I am interested in what kind of skills does plant almond walnut have to uptake micro and macronutrients. I know that nitrogen absorption is much more easier than other PK, for example, or other. I'm interested in this skill. I have some information that we have to apply a higher quantity of potassium in order to be uptaken plant, because it needs high pressure. Plant needs high pressure. And can you explain us physiologically what kind of skills does plant have for uptaking the nutrients?
Yeah, so this is a really important question, and nitrogen and potassium are really different in terms of the physiology of uptake. I mentioned diffusion versus mass flow. First of all, potassium is taken up through the process of diffusion, which is an active energy requiring method of plant nutrient uptake, and whereas the nitrogen would be taken up during through the mass flow, through the transpiration stream. To add to the complexity, potassium, like there was a mention on one of the slides, potassium can really be immobile in certain soils, so it can bound to the soil particles. So the potassium can be hard to get into the soil solution from the soil particles. So that makes potassium management a little bit different. Having said that, if you have a soil situation where the potassium is really hard for the plant to uptake, then I would say that in those cases, a lot of growers rely on foliar applications, supplementing potassium in season through foliar applications. That's one strategy.
Because when we calculate the yield, we have to apply the fertilizers according to the yield, yes? And do we have to apply more potassium than it is in our calculation? This question goes to this.
Yes, so I have, in this presentation, I also have some numbers for potassium uptake. I think how much potassium for each 1,000 kernel pounds the almond trees would need. So that is really a question of your particular site and how much how much potassium you can really be bound in the soil particles in your particular soil texture. So I can say this time to answer your question that you can really get a sense of that through monitoring. So you have your potassium numbers from last year on the leaves, and you have your potassium applications in fall or foliar applications, and then you can look at your yield, how much potassium your nuts are removing versus how much potassium did you apply, and then what is happening to your leaf potassium levels. Are they staying stable or are they going down? So based on those technical considerations that you can probably come up with an estimation on how much adjustment you will need to make for your.
Yes, for it I have to be a scientist. So.
So in some cases you really need to explore when you're managing the orchard, and that's what precision management is all about. Yeah.
Okay, thank you. Next question according to zinc. We have some zinc problems. You showed us small size leaves. One day it seems nothing with the tree, and the next day I see the walnuts going. It's a disaster. And we are applying in every application zinc, chelated form or sulfate form. But I think we need more to apply, and from the drip irrigation. How do you think, when you have such kind of problem, it's better to correct in every pesticide application or apply more quantity through the drip irrigation?
Yeah, that's really, things like that make the management really challenging. But remember, zinc is an immobile or partially mobile element. So wherever you apply or when you apply, so you correct the deficiency over there, and if it's not being actively taken up throughout the season from the soil through xylem, it is basically not going to move to the new growth. So every time you have new growth, then you would need to apply zinc, and in a chelated form or in a form that can be readily taken up by the tree at that particular pH level.
It's
So
the same with boron.
if you have a high pH issue, and your trees are really not taking up boron from the soil solution, then the only solution would be to actually keep replenishing foliarly or through the chelated applications of chelated zinc that aids the plant in the uptake through every irrigation or every other irrigation. So continuous replenishment.
Okay, what about zinc or other nutrients? Which formulation is better? Because I know some organic molecules may be big size and the leaves cannot uptake it. So which is the best formulation, for example, take zinc for foliar application?
I have not come across any information on almonds yet, so I cannot speak to the different forms of zinc. But tomorrow I can bring up some slides on some work on different zinc forms in pistachios. So that way you can have a sense of I know I have somewhere in my folders that slide that talks about different rates of zinc and different forms of application of zinc in pistachios. So maybe that could help at this time, but maybe
The
we
walnut chips also it will be good idea.
Okay. I can definitely look it up.
I phosphorus the market phosphorus deficit two solar phosphorus deficit the market two solar გავიგეთ თქვენ გითხარით რომ არ შეგვიძლია შევამჩნიოთ სცენარის phosphorus deficit-ი solar გავიგეთ იქ მაღალია
Over my 12 years of working in California almonds, I came across one field that had phosphorus deficiency. So we were able to identify the phosphorus deficiency from the leaf symptoms, but because it's so rare, we were really perplexed at what that deficiency is. So yes, and depending on the severity of deficiency symptoms, you can identify the phosphorus deficiency. But I don't have much experience in working with phosphorus deficiency because in California, phosphorus is quite abundant in soils natively.
In Georgia it's opposite. I may შევამჩნიეთ ჩვენ ვახში ფოთლები აი მე გადავხედე სხვადასხვა ინფორმაციებს და იდენტური გახდა და შემიძლია გაჩვენოთ აი ფოტოს საიტვენიაზე და მაგის შემდეგ შევიტანეთ ფოსფორი და რაღაც პერიოდის მერე ეგ რაც ჭირდა გადავიდა და ჩვეულებრივად გახდა ისინი შემიძლია გამახსენოთ.
Definitely, and that is the kind of feedback that I'm really looking forward to, right? Because see, this is one situation where I can bring all the information from California, but you would need this particular information here. And I know that a lot of people have used mycorrhizal to enhance phosphorus uptake. And do you have any experience of using mycorrhizal?
No.
The WAM, the vascular or muscular mycorrhizal, the fungus that have association with symbiotic relationship with the roots, that will really help in phosphorus, enhancing phosphorus uptake. So if you have a phosphorus deficient soils, I would recommend you explore the mycorrhizal products. There are a lot of companies these days working in mycorrhizal products. And coupled with phosphorus applications, because remember, if you have phosphorus deficiency, you cannot just rely on just slugging phosphorus in the soil and then just praying for its uptake, because phosphorus can really bind to the clay particles and become unavailable. So aided with the application of any product that creates that vascular fungi, the symbiotic fungi, that will enhance the root hair development with that symbiotic fungi. That will help in phosphorus uptake.
The question is, just Albert is asking if we can give the mycorrhizae with drip irrigation, mycorrhizae product.
That's really,
Technical question.
I have a good connection that I worked with in the past. They have developed some products. I have to check, at least I can check with him, or I can go to their website. They were really into the mycorrhizal research, and I'm sure there will be some products that we could apply, but I'm not sure of that at this time, but we can definitely check.
Is Trichoderma harzianum also mycorrhizae or it's different? Trichoderma harzianum is also mycorrhizae? Trichoderma harzianum.
Trichoderma, okay.
Trichoderma. Okay.
Yeah.
Sorry. The question is about, if we apply, the chelated micronutrients that we have, of course we can apply through the soil, and they will be available for a while for the plant. Okay, let's say iron, we have EDDHA, we have DDPA of the iron, depends on what kind of pH we have. Also we have zinc, chelates, And that's, that's kind of easy. So we can give zinc chelate, and that's kind of relief. But let's say boron is not chelated, and we have, let's say we have 8.1 pH in the soil. If you're irrigating with, let's say, a little bit acidified water, so if we bring the irrigation water pH with, let's say, sulfuric or nitric acid to like 5.5, is it going to help with every irrigation to uptake the boron? And it's going to be kind of solution for also different micronutrients, or it's not going to help?
Right. No, that's the practice that many high pH sites in California follow. Acidification through the acid, sulfuric acid. There are companies based on just sulfuric acid supplying through the irrigation system. So that is one of the proven strategies to actually help reduce the pH for enhancing the uptake.
Nitric acid is also okay, because we have nitric acid production here in Georgia, and it is quite cheap. Is it okay to acidify with nitric acid?
I will have to check. I'm, because I know a lot of farmers and they apply sulfuric acid, but I have to check about nitric acid. All right, so let's move on to this. So
one more question, please.
Yes.
My first question is, you have already mentioned that potassium helps diffusion in the root zone. How potassium helps diffusion during winter time?
From diffusion is basically the process of uptake through the process of diffusion, right?
Yes, but in winter time, when plant is in the state of hibernation, there is no active upflow. So it absorbs nutrients only in a way to be diffused. Yes, and how you mentioned potassium helps diffusion. How this element help to diffuse?
So yes, so basically the mass flow would be a method where you would need active transpiration, and the nutrient elements like nitrogen, they are a part of the soil solution, and as the tree is drinking water through the transpiration stream, those nutrient elements are getting picked up. So the diffusion is basically the process at the level of exoderm, the outer layer of the root, where the root meets the soil or the soil solution. So cations like potassium, they have some potassium transporters back and forth going into the root cells, out and inside. So the process of diffusion is basically the concentration gradient. So when you have the higher concentration outside, then potassium actually diffuses into the root through the process of osmotic diffusion. So I still have to see for particular. I have to check particularly, if the soil temperature will have an effect on the movement of potassium during the winter months. But I have seen as a standard practice that potassium is applied in fall into the soil, and it is basically taken up by the tree to build up the potassium reserves for the next season. But it's not dependent on the actively transpiring leaves to be.
I have a small question.
There it is.
We talked about foliar and soil analyze, and I have a question if there is other analyses, like for example, from nut or harvested nut.
I mentioned the hull samples for boron. The hulls of almond, they are a big sink for boron. So for checking the optimum boron concentration, you really get the hulls tested. So that is one practice that we follow in California. Other than that, the kernels nutrient content, not so much in overall production management. So I would get the soil samples tested, the leaf tissue tested, and the hull tissue tested, and that will give me a good picture of all the macronutrients and micronutrients. The kernels, hulls for that reason, because it's a sink for boron. It captures most of the boron. Other than that, because my nutrients are getting removed from the orchard in terms of my nuts, so the research has already shown that, for example, non-pro, 1,000 pounds of non-pro kernels remove 68 pounds of nitrogen. So that is what has been determined by research in California. So we already know that. So we don't need to necessarily get the kernels tested every year. Okay.
Thank you.
All right.